2018, this is...
Okay, 2018, this is a restricted answer, question 1. The diagram illustrates thermoregulation in mammals following a decrease in body temperature. So we have, this is going to be important. The fact it says decrease means that we're going to talk about decrease, okay? So we've got our normal body temperature here. Here. You have a decrease in body temperature, which leads to thermoreceptors in your brain recognizing that, sending information to the skin, a corrective mechanism, bringing us back to normal temperature. So this is, you should recognize, negative feedback. And you could say that this is also physiological homeostasis, but check the mark scheme for exactly what it accepts. Name the part of the brain in which the thermoreceptors are found. No option on this one, this is the hypothalamus. State how information travels to the effectors in the skin, right? So there are two mechanisms by which you can get information from a negative feedback loop. It's either going to be nerve or it's going to be hormone. Now, if it's hormone, you're looking for a longer lasting response, but it's going to take a little bit longer for it to kick in properly. Nerve, however, fast, and that's what you're going to use here, because you need a quick response to change in temperature because you cannot allow it to go very far. Okay, effectors in the skin include muscles in the walls of blood vessels. Describe the response of these effectors to a decrease in body temperature. So muscles in the walls of blood vessels. So what you're looking at here are your skin arterioles. And what we're talking about here is, because you have got colder, okay, is vasoconstriction. Oh, misspelled that, excuse me. Vasoconstriction. So what happens there is we have our skin arterioles, thin tubes, which have blood flowing through them, and that means that we have heat lost from them just by radiation. Okay, so if we constrict these, so we tighten muscles around the outside of these, making them thinner, you get less blood flowing through and you get less heat loss by evaporation. Okay, so the response of these effectors to a decrease in body temperature is to tighten, or to cause them to tighten, but basically, can't spell that word at all today, vasoconstriction of the skin arterioles. So that's the describe. Okay, then it asks to explain, and this is, it decreases heat loss by evaporation. Oh, sorry, I don't want to say evaporation, I want to say radiation. Evaporation would be your sweat. So by radiation. Okay, explain why it is important for a mammal to regulate its body temperature. Now, there are two specific content points on this one. What I'm expecting you to go for is that it maintains the optimum temperature for enzymes. So that means that they're most active, that they work at their best possible point. But what's also a content point, and you should recognise it, is that this also maintains the best diffusion rates. Okay, because diffusion is linked to concentration. Concentration is linked to solubility, and solubility is linked to temperature. So there's a kind of knock-on effect of this. So the best diffusion rates are where you've got good solubility, giving you a high concentration to allow you to get a good high to low gradient. So you could say just your best diffusion or high diffusion rates. Either of those would get you the mark. Okay.